So you've been hearing about MCP servers ever since they broke out as a trend, and you've seen many implementation videos. I myself have made many of them. But today, I'll be telling you how you can actually implement your own MCP server and configure them to your own liking. This is not going to be a general tutorial because I'm not going to teach you how to code. I'm going to give you the concept of how these MCP servers work and then tell you how you can use AI to actually generate those MCP servers by giving them the useful context. So let's jump right in. So this is the documentation for the Model Context Protocol. If you look here, you'll see different software development kits for various languages, including Python, TypeScript, Java, and Kotlin. You can choose whichever one you prefer or feel most comfortable with. I'm going to go ahead with the Python SDK. As you can see, we've opened the Python SDK GitHub repository, and down here, in addition to the installation guide, they've provided a pretty solid quick start guide as well. This guide walks you through the basics of building your MCP servers, and once you understand those fundamentals, you can pretty much build anything you want. You can install it using pip. So just open up your terminal, just type this command, and it will install the MCP library for you. After that, head over to Cursor, create a new folder, and then create a new Python file. Let me quickly explain this to you. Here you can see that I've imported the library. The library provides the MCP class, which I've used to create an MCP server. Using this decorator, I've defined a function that converts dollars into pounds. This function takes input from your provided source, processes it, and returns your preferred output. Right now, it's using a fixed exchange rate to return the converted amount. This part right here is the model's context, which helps it understand what the tool does. You can think of it as the tool's description. This context guides the model in deciding which tools to use in different situations. Once you've defined this, the next step is to go into your settings. Inside the settings, navigate to the MCP section and create a new MCP server. But before that, make sure to copy the file path. In the MCP menu for the name, you can enter anything you want. This is just a nickname. Let's call it our first MCP. For the type, simply keep it as command. For the actual command, you'll write MCP run followed by the file path. Then click add. This will add your tool, and as you can see, our dollar to pound conversion tool has been successfully added. Now, the agent in Cursor can use it. Let's go ahead and test it out. Opening up the agent, we'll ask it to convert $20 into pounds. Now let's generate the response. You can see that it's using the MCP tool, making the call, and passing the amount we provided as a parameter. The function processes it and returns the result, which is then displayed in the chat. This is a very basic example of how MCP servers work. Essentially, you can think of it as a simple input-output process that allows you to build and use tools efficiently. Before moving on to a more practical implementation, I want to point out that you don't actually have to build all of this or learn the syntax yourself. You can provide context by giving it the documentation for the SDK you're using. Now, how do we get the documentation? The documentation is actually inside the README file. As you can see, the entire README serves as the documentation. In addition to documentation on tools, it includes others like image documentation, prompts, resources, and more. To provide this documentation to Cursor, we need to add it as a doc. First, get the address of the README file. Make sure it's the README file itself, and not the entire GitHub repository. The full repo won't be useful and will only increase the context size. Once you have the link, go into Cursor. In the Features section, scroll down to the Doc section, add a new doc, paste the link, and it will index it and save it. You'll also need to give it a name. As an example, I've already added mine under the name Python MCP SDK. This helps provide context within Cursor. Now, to use it in Composer, simply reference the docs, select the one you added, and from there, you can build anything while having that doc as context. If you want to take things a step further and and make the documentation even more accessible for learning or asking questions, you can convert it into LLM readable data. To do this, go to GitHub and replace hub in the URL with ingest. This will open Git ingest, a really cool tool that converts any GitHub repository, or at least the portion you specify, into a full knowledge base for an LLM. Once converted, just copy the output and provide it to any LLM, allowing you to ask questions or learn from it effortlessly. Okay, so now that we've seen a basic example, let's try to build something more useful. We're going to create an MCP using Crawl for AI, which is an open source web crawler and data extractor. The installation instructions are right here, and it's really easy to set up. Just install it on your system or in a virtual environment if you want to avoid package conflicts. As I mentioned earlier, this isn't a tutorial. I'm just showing you how you can use AI to get things done. Now they've provided a simple script that extracts data from a given URL. I took this script and pasted it into Cursor. Here it is. First, I checked if it was running correctly. Once I verified that, I gave Cursor this prompt. I asked it to look at this file and take the function from it, then implement it into my first MCP file, which already has the MCP structure. I also instructed it to accept a link as a parameter. This means that whenever we provide a link, the AI model runs it through this function and returns the result as a markdown file. From there, we can do whatever we want with the extracted data. And look at this, the Crawl for AI web tool is available to our Cursor agent. I don't need to change the address since it's in the same file. I've also tested it out. You can see that I provided the link to the Cursor website and asked it to crawl the site and list the sections it contains. Now, it did return the sections along with brief descriptions of each, but let's actually take a look at the output. The parameter we passed was the Cursor website link, and in the result, we got both the structure and the content of the site. You can see that the text from the website was extracted, but we didn't get the full structure like the HTML tags and other elements. To get that, we'll need to configure it or refer to the Crawl for AI documentation. By doing that, we can extend our MCP server to not just crawl a website, but also give the data required to accurately clone it, making the process of duplicating landing pages almost instant and incredibly fast. Alright, so what you just saw was me using a tool I have locally installed, but you can also work with APIs. For example, I have the documentation for the Figma API endpoints here, specifically the getFile endpoint. What they've explained here is how you can extract the required parameters for this endpoint directly from the Figma file URL. Now, just pass this to the agent in Cursor, and it will automatically generate the code to extract those parameters and implement the MCP server for you. As I mentioned before, you need to think of this as a simple input-output system. Using this approach, you can create MCP servers for almost anything, whether it's with locally hosted tools or API endpoints. Just think about it. Any platform with APIs can be controlled through an agent, and that's pretty mind-blowing. So, we hope you enjoyed this video and learned something useful. By using this, you can implement your own MCP servers and boost your productivity. Don't forget to like, subscribe, and turn on notifications to get to our videos first.